All right, calculus, welcome to section 5.4, the fundamental theorem of calculus, part 2. All right, write these down in your lovely notes. Here it is. If f is continuous on the interval a to b, then the integral f of x dx with bounds a to b is simply the antiderivative evaluated at b minus the antiderivative evaluated at a. You already know this, where f is any antiderivative of f, that is, a function such that the derivative of the antiderivative of f is the original function f. Okay, that's literally what we've been doing when we've been doing some basic integration, okay? So here's a little review question for you. Evaluate the integral. So let you do that one first. E to the x dx with bounds 1 to 3. Try that on your own. All right, this one does have a little bit of a nice review section in here. Again, tell your friends. SLU, though they're online, has not been canceled. So you need to continue with your learning. These videos should be getting several more views. All right, you need to continue with this. Got to keep going, folks. There's stuff we still have to learn. This is not a 2-week vacation for you. It's probably going to go longer, and we're going to have to do more learning with calculus via these videos. Anyway, the antiderivative of e to the x is e to the x. Evaluate that antiderivative at 3 and 1. So there's an answer. You can factor out e and call it e times e squared minus 1. If you wanted to call it e times e plus 1, e, and then times e minus 1, that's fine, but that's a great answer. Evaluate the integral. All right. Another way to write this is 1 over x. The antiderivative of 1 over x is natural log x. Evaluated at 6 and 3. I think we did one like this in class. That is the quotient property. What Algebra 2 and Honors Algebra 2 is having to learn via video right now. That's natural log 2. All right, here's a new one for us. Find the area under the parabola y equals x squared from 0 to 4. This is one of the first questions we did this chapter, and I checked my work by evaluating the integral. So x squared, again, here's what we're looking at. This could be that sweet curve from 0 to 4, something like that. I want this area. Okay. It's not a triangle. It's got curvature there for sure. So what I do is I integrate. The integral of x squared is 1/3 x to the third. Upper bound 4, lower bound 0. There we go. 64/3 would be my area. Number 4 here. Again, pause this whenever you need to. Find the area under the cosine curve from 0 to pi halves. So that is what I want right there. That is roughly the cosine curve. It's got some, it's really best when you make the whole, graph there, the whole curve. So I tried my best. All right. The antiderivative of cosine is just regular sign, positive sign. The derivative of what would give you cosine? The derivative of sine. Okay, sine pi halves minus sine 0 is an area of 1, exactly 1. All right, so on this next page, if I'm not mistaken, folks, we also have a studio audience here. They're a little bashful, but they are eager to learn. All right. Anyway, here's just another fact. If you need to switch the bounds, remember it's always lower bound to upper bound. That's written out of order. If you need to switch the bounds, just write it like that. Switch them, but then it's the opposite of that integral. You would evaluate that. Anyway, that would be your answer. Make sure you have that down. Then, folks, I'm going to give you a little bit of time to practice these. This is Fundamental Theorem of Calc Part 1 review. Try these first, and then look at the work and the answers. So there's A. Write it down. If you need to pause it right now, go ahead. Here is B. Write it down. Again, I want the derivative of this integral. Fundamental Theorem, Calc Part 1. There's C. A little issue on C. You see that? Uh-oh, a little issue on D as well. And then there is E. So as it says, try them now. I'm not going to pause it. I'm going to, there's going to be a little dead space here. Time for a coffee break brought to you by Cameron's Coffee, Caldy's Coffee, Caribou Coffee. All the coffees getting me through this time. Okay, try those real quick, and then we'll go over the answers in a sec. All right, if you need to pause this video to work on them. I would highly recommend that. So I'm going to give the answers here in a sec. Again, you might have to be doing a lot of learning via these videos, via this practice. So get in the habit of learning how to do this, folks. Because no matter what, you're going to have things due, okay? You're going to have to turn things into me. There's quizzes and exams still to be taken no matter what happens. SLU's not being canceled, okay? So we got to learn. Anyway, the first one, folks, simply plug x in for t. Take the derivative of x, which is 1. So that one is simple. On B, also just plug x in for t. No big deal. Now, if you've noticed, C has the incorrect bounds written there. X has got to be the upper bound always. So you're taking the derivative of the opposite of that integral now. Plug x in for t. The derivative of x is still 1. That would be my answer. You can help each other out, folks. Help each other out. Bounds are incorrect. Flip the bounds. Now you're taking the derivative of the opposite of that integral. Plug x in for t. Again, the derivative of x is still just 1. So that would be my answer. Now on E, what I'm plugging in for x is square root of x, or what I'm plugging in for t is the square root of x, and the derivative of that is not 1, okay? Bounds are written correctly. Plug the square root of x in for t, and then again, I forgot to write it when I first wrote this out. I got to take the derivative of the square root of x, which I still didn't do. I'm just telling myself, hey, don't forget, take the derivative of the square root of x, which I finally did. The derivative of the square root of x is 1 over 2 root x. I just put it at the bottom. All right, that is a decent amount of work on the fundamental theorem of Calc Part 1. I would pretty much, I don't know, would we go over like 9-10 questions total? One of those will be on the final for sure. And the last part of section 5-4. And then, I don't know, probably on Monday, we'll start going over U substitution. Probably on Monday. You should use the rest of the time to work on that homework. Work on the questions that I tell you can do for quiz number 2. Keep reviewing for quiz 1. We'll go from there. Section 5-4, the average value of a function. We define the average value of f on the interval a to b as this. Fav, that would be the average value of f. Fav is equal to 1 over b minus a, the integral of f of x dx from a to b. So for a position function, we think of this definition as saying that the height is simply the area divided by the width. All right. The area divided by, this would be the width, that would be the area. Average value of function. So find the average value of the function. F of x is equal to 1 plus x squared on the interval -1 to 2. Again, That's f of x. That's the interval. Fave would be 1 over b minus a, that integral. So 1 over 2 minus a negative 1. The integral negative 1 to 2 of 1 plus x squared dx. I'm going to integrate. In a second, that's 1/3. 1/3. 1 plus x squared. Now it's time to integrate. X plus 1/3 x to the third. I just leave that 1/3 on the outside there as I did. I'm going to plug 2 in for x. Minus, plug negative 1 in for x. That 1/3 is still hanging out on the outside. 1/3 of 6, which is 2. Average value of the function, 2. I got 2 more of those, and then that will be it for section 5.4. Find the average value of f of x equals cosine x on 0 to pi halves. 0 to pi halves. We just did the area, right, under the curve of that. So pi halves is b, and a is 0, so it's 1 over pi halves minus 0. I know that looks weird. So if you have 1 over pi halves, that means it's just 2 over pi. What is the antiderivative of cosine? It's sine. All right. Plug pi over 2 in. Plug 0 in. We know that that area is 1. The average value is 2 over pi. All right, one more here. And pause this whenever you need to. Find the average value of f of x is 1 over x on the interval 1 to 4. So the average value is equal to 1 over 4 minus 1, integral 1 to 4 of 1 over x dx. 1/3. That's what, 1 over 4 minus 1 is. The antiderivative of 1 over x is natural log x. Going to plug 4 in, going to plug 1 in. Natural log of 1 is 0. That is 1/3 natural log 4. All right. Anyway, so what is today? Wednesday. Section 5.5 might come to you on Friday, most likely on Monday. And then I'll give you a lot of examples for section 5.5. That is a huge one, especially if you're going to continue on with calculus U substitution. All right, folks, get on that in homework set number 2. Keep reviewing for your quiz. I've given you some hints for the integral homework set. Anyway, be working on that homework. Make sure you got these notes. Write these notes out again. A lot of examples. In the Can't Hurt Me book, that's what David Goggins did. Wrote out his notes again when he finally got to learning well. Anyway, folks, help yourself out. Try to figure out ways where you can relearn things well. All right? This is going to get you prepped for that harder learning in college. Anyway, stay safe. Yak Math Videos signing out.